laminar products, grids, and diffuser. The content of this presentation is going to be represented right here. We're going to have the difference between diffusers and grids or screens. We're going to have also how to select them, ceiling diffusers and selection, grids for supplying and the selection, grids, selection, all the summarize of the products. The diffusers are elements in this case that are always installed in ceiling or also in the ceilings. They never have to be installed in vertical walls. They have better distribution rates. The grids are installed generally in vertical walls. They have a low index of thermic induction, and they can manage the earth in this for the ceiling. So it is selected by the NC numbers, which is the criteria depending on the application. Also, the amount of the diffusers is selected depending on the height. We need to keep in mind what are the diffusers, minimum diffusers amount requires for the areas. We also have to select the number of diffusers and the geometry of the place and the distribution of the pipes, and also the selection as well. So first of all, we need to select the NC or the criteria depending on the application. So every application by itself in areas. Depending on these applications right here, office buildings, private residencies, schools, depending on the installation for the air supply. So we need to have the noise criteria range for making the installation of an element that is going to be distributing the air. Second, we need to determine the amount of air depending on the height. So here we need to calculate the minimum amount of diffusers required. So it's important to note what are the areas or the height. So this is going to give us a maximum T, which is a difference of temperature, maximum temperature that we need to have for the air depending on the diffuser and the air mix as well. So here we select DENT, or we make a calculus of what should be the number of minimum diffuser that I need to select the number of diffusers depending on the geometry of the place and the distribution of the pipes. So we can have two sides, two ways, different characteristics, and it's going to tell us if it's enough with these 1 or 2 ways or 3 or 4 ways. And 4 is selected in regards to the guides of selection. So it's important to understand that every single diffuser has a chart just like this. It's a guide for selection, and this shows the features or the characteristics of every diffuser in regards to, for example, flow, noise criteria, and these features or characteristics are related with the geometry or the size. So we can find some charts, guides for selection, and they are different depending on the type of diffuser, the type of the grid, and different manufacturer is the LGS. This diffuser LGS is manufactured for the air, distribute the air in the several directions depending on the necessities for the configuration established in the construction. There is a limitation for this type of diffuser, and is that the air speed should be as maximum as a recommendation 700 fp per minute, because over that the diffuser is going to be affected, or the noise level. So there are some applications in which this speed is increased and the noise as well, so it's going to require a different diffuser. The formation is over 6 inches up to 24 inches in pairs and measures 2 inches and 2 inches, and there is no we don't have the 9, 15, or 21. So the options for manufacturing with damper OB is one of the options that we have for this kind of diffusers, and there could be an electrical actuator. That is also an option for damper parallel to the manual mechanisms or shooter. And there is a guide for selection independently for every single air distribution way for every single diffuser. The diffuser, it's limited up to 2.5 or 3 meters height. Over that height, with this kind of diffuser, it will be a little bit not an option because there are some other types of diffuser that could be used for better or for higher heights. It could be manufactured square, rectangular, in 4 ways square and rectangular, in 3 ways square, in 3 ways rectangular, 2 ways in 90 degrees, 2 ways in 180 degrees, and it could be also done like this. So who makes the selection of the all kind of directions or ways for the diffuser to be installed? Well, the designer, the diffuser by itself has a central panel. As you can see right there, it's fixed. This panel, it cannot be moved. So this is the shape or the geometry when we see the diffuser from the bottom to the top when it's installed. So it's very important. So right here, we have some measures, references of the diffuser. All the diffusers and all the grids are referred to this size in the neck, let's say it. And every time there is diffusers required, so we take into account this nominal measure is the real measure in the product. So you need to keep into account that we need to keep in mind this factor in order to get the real measure of the product. So if I have a diffuser LGS 12 times 12, the real measure in the neck is going to be 11. Right here, we can see, for example, the factors that we need to keep into mind in the diffuser is the installation or the procedures. For example, the damper for the airflow. But it also has some effects in the diffusers and also over some of the characteristics or features of diffusion that, number one, the throat could be up to 95%. The total pressure is increased in 5%, and the noise criteria is increased in 2. So right here we can see a graph where it's show the reference in regards to the flow: 200 CFM, 450 CFM, 800 CFM. So what are the throw that we can get with that diffuser once we increase the flow? So we need to understand that the diffusers are elements that have low throw, but they have a thermic index very superior than compared with the grids. In the selection criteria or selection charts, we have characteristics like this, like the designs. We're going to have some values, speed, for example, in which the air is arriving through the pipe or in the pipe, yes. So this speed, this velocity is 100, 200, up to 900, the neck velocity. Also, in all the columns as well. And in the rows, we can see right here that there are some features or characteristics for every single diffuser in squared measures, 6 times 6 up to 24 times 24 inches. Of course, inside the chart, we can see different features. For example, flow, CFM, noise criteria, as well, CFM per side, and throat of the diffuser, throw in set. So if I have a diffuser 12 times 12 that is receiving, for example, 600 ff velocity in that diffuser, we're throwing 575. The noise criteria is 34, and the throw, the CFM per site, oh, sorry, the throw is 31 feet. So right now we're going to talk about the diffusers on ceiling, LAV. So they are different to the LGS because they have a central panel in the structure and in the geometry. So there are some different geometries. So they made this diffuser LAV to have better performance characteristics compared to the other diffuser because they are manufactured for the injection through ceilings in dry walls. They are developed to distribute the air in different directions. And different to the former one, to the last one, is most robust and more is heavier, and the throat can cover bigger areas. Besides the following characteristic, it could be used for velocities up to 900 fpm and even to speeds or velocities at 1000 fpm, and it could be applied for pipes of high velocity. They are manufactured from 6 times 6 up to 30 times 30 up to 3 inches, and it means that it could receive air velocities, and it makes the noise criteria not to be affected because of the geometry, because this geometry makes a better throat. It accepts rectangular combinations between 6 inches up to 30 inches. It could be done in a flat area, depends of every single characteristics of the presence of the diffuser, that it's going to be selected by the designer, of course, and it have the damper option, damper OB, with electric actuator. It works really good up to 5 meters height. Different to the LGS diffuser that only works up to 2.5 or 3 meters. This is also manufactured in 4 ways, 4 directions, rectangular, square, 3 ways, square and rectangular, 2 ways in 90 degrees, 2 directions, 180 degrees, rectangular and squared, and 1 way. The diffuser, as we have explained previously, it has this removable panel, and right here we can see that the these elements for the air diffusion, they have some specific or determined angles for having some specific air diffusion characteristics. So right here we can see a chart for the selection of the diffusers, LAB 4 ways. It shows some features, velocities, for example, of design. They are always going to be given by the design of the pipes here in the columns, and then in the rows we can see what are the main measures for the product to be manufactured. And these measures right here show us what are the characteristics, the main characteristics of the diffusers once we are increasing the velocity. So the diffusers that we have is the ceiling LCL. This one is a diffuser that has some characteristics different to the other diffusers we have talked before. They are manufactured for the diffusion of air through the ceiling or drywalls, and they are developed also to send the air in different directions. They are curved, and they could be a cure for these allow to be closed or opened for the distribution. When we can change the cone of the distribution of the air, could be done for specific areas, and they made the diffuser to be useful in some heights over the 5 meters. So they are manufactured from 4 inches up to 24 inches, being increased every 2 inches. There is one that it has only one weight, could be manufactured up to 48 inches times 34 inches. It also has set rectangular measures, increase in 2 inches. It has also the option of the damper OB, and it works very good up to 8 meters height with the characteristic that we just mentioned before. It's movable, so it changes the cone of the distribution of airs. It could increase the areas, and at the same time, the levels of noise are decreased, and it could be done or installed in heights over 5 meters. So it could be manufactured square, rectangular, four ways, three ways, rectangular, square, three ways, 90 degrees, two ways, 180 degrees. Right here, we can see the flap of the diffuser. So these kind of flaps or elements, they allow us, they are plastic and they allow us to be movable. They can be moved. And there is no contact metal with metals. And these reduce the vibration or avoids the vibrations with metal that is manufactured. In the manufacturer, the angles that are recommended for the flaps, those angles could be changed for the flaps, and there are some characteristics in the charts for the selection, depending obviously on the positions of the flaps. So this provides some range, and we need to keep into account these ranges depending on the areas that are going to be used and the design of the product that is going to be selected. So we need to keep into account the flaps are movable. So this diffuser, for example, is going to have different to the first one. It's going to have better folds or throats when air is coming through this product. This chart changes a little bit, but the characteristics are almost similar. So this is a diffuser that could be manufactured rectangular, square, different to the other diffuser that we've seen before. So right here in the columns, we can see diffusers with some specific characteristics. 14 times 14 is similar to a 20 times 10. We can see right here deflections. The flaps are movable, so we can have the diffusers in different directions established. One position 1 to up to a position 4, or a position 1 with flaps a little bit closer, or 4 with open flaps. So it means that this diffuser is giving me a range between 15 feet and 22 feet for 400 CFM. And it's guaranteeing a velocity in the 330 CFM. Now we have the grids. These supplying grids, as we saw before in the difference between grids or ventilation screens and diffusers, though they are elements for injection, for air injection through walls or vertical surfaces, which is very important to understand. The flaps that guides the air, they have aerodynamic characteristics for throwing the air, and they are recommended for applications where the air is controlled in dispersion. We have 4 models of grids or screens. In these 4 models, we have the LV, which means that the flaps only have one vertical direction. We have the LH, though they have flaps in horizontal direction. We have the LVH, they have vertical flaps in the front and horizontal in the back. And the LHB, they have grids or screens with horizontal flaps in the front and verticals in the backside. Features, characteristic, they could be manufactured and measures 4 inches up to 48 inches, increasing every 2 inches. It accepts all the combinations, rectangular combinations. It measures 4 inches up to 48. They can also have the damper OB. And right here, we see the characteristic of the grids or the screen. So the flaps right here, they could be horizontally installed or vertical. So these flaps are held in a plastic elements, and these elements allow us to organize or set up the flaps vertically, or the dispersions, or the horizontal for the fall, for the throw. When air conditioning is being used, the horizontal flaps, they have to be in the top because there is more density of the air. So we need the air to arrive or to reach the bigger throws and then start falling down by gravity. So here we see a graph that shows us when the air is injected with these low volumes or low floats, we are going to obtain some throw in the grids that are over the diffusers. So the grids are elements that are used in order to bring or to take big flows or volumes of air in superior or bigger distances. So this grid or this screen manages big flows, and the distribution is lower than the diffusers, but it could reach superior distances. So here we have the selection charts, and we can see right here that grids, some have the same characteristics for the selection. 10 times 10 has the same characteristics of 12 times 8, 18 times 6. They are similar. And right here, we can see that there are different deflections. So we can have flaps with 0 degrees, 20, with an opening of 22 degrees or 45 degrees. And those openings makes throw in feet that we can reach when the air supplying is done by using these kind of grids. Now we have the returning grids. These return grids are grids that are used for returning the air that is already, let's say, dirty to the air conditioning system. So they offered an effective area and a minimum of visibility between an area and another area. So we have several different grids that are in the catalog. So we have the LRA, those are grids or screens that are manufactured with fixed flaps supported in the framework, and they have an inclination of 38 degrees in regards to the horizontal. We also have the LRF. They agree with central panel that could be moved. It allows the installation of a filter for purifying air, and they can be used in fan coil systems where, for example, this central panel is movable. It could be open, could be closed as well, for making inspection, visual inspection, for example, of what is inside of it, and also for changing the filters. And also we have the LRAG. Those are grids or screens manufactured in this measure like a cube. And they are the grids or the screens that has an effective area, effective that is superior than any other grids. Characteristic, they are manufactured from measures 4 inches up to 48 inches, increasing every 2 inches. And they could be, they could have combination, rectangular combination. It could receive or could be installed the damper OB, the flaps. In this kind of grid, they are always horizontally installed. And as a recommendation for the installation of the ventilation of the flaps, they could be installed to avoid the dust. So they could be pointing to the bottoms. We also have the LDGD is manufactured to be installed in modular divisions or doors in central panels. It has a profile, which is like an inverted Y that avoids the visual contact. In the LR8 grid, they have these characteristics. These flaps are totally fixed, and they are fixed to the frame. Right here, we can see the profiles. Is a flap like an air blade that permits the air when it's passing not to cause a turbulence, inner turbulence. So these are the LRF grids. They have a central panel that is removable, which could be open and closed depending on the conditions of maintenance in a specific application, and also could be installed inside the grid filter. The LRAG screens, they are like a cube. So they allow or they permit a high effective area in compared with the previous grids, which also helps that when making the selection of these kind of grids, also we can obtain measures, inferior measures. So for example, right here, the central panel is manufactured totally in aluminum. Also, we have here the LDGD grids. They are grids or screens that permits to be installed indoors, for example. And when they are installed indoors, because of the flaps that they have, which is an inverted Y, there is no visual between one area and the other area. For installing the returning air grids, we need to keep into account several points. So first of all, we need to select the velocity inside the range recommended depending on the application. It's also important to determine the CFM to return on the grid depending on the calculus. Also, it's important to select the size of the grid or the screen in regards to the selection charts. For the returning air grids, we have these standardized charts which tell us that depending on the application that we're going to have, there are some minimum and maximum recommended velocity of the air to be returned. Therefore, depending on these applications, as I said before, there is a range, and this range tell us what are the velocities, recommended velocity as minimum and maximum. So right here we have the listed size, the selection charts. So right here I have to see first the columns, and I obtain the velocity in which I am going to be returning the air. So this velocity has or comes or is given depending on the application. After that, after obtaining this velocity, return velocity, I can select what is the flow to be returned. And after selecting the returning air float, I need to check in the rows. I'm going to be able to find what is the grid or the screen or the size of the screen that better fits for obtaining or for returning, in this case, this amount or this float of air that I want to return through the grid or through the screen. Now we have LBG or linear grids. So these kind of grids or screens is a product that is designed for eliminating many of the problems that could be presented on the ventilation, because it's a very good product. It has a very good appearance. So as characteristic, they could be presented in fixed angles of 0 degrees, 15 degrees, 30 degrees. And this also helps for the distribution of the earth. The central panel of the grid is removable, which also helps for the installation of the grid. It's a grid or a screen that could be used for long or for big lengths over 72 inches. And right there, we can make a modulation And what we do with this modulation is not to lose the flaps, and in order to obtain dimensions over 72 inches, keeping always the aesthetic or the appearance. It could be also used for different applications in the floor, and could be done also in the corners for creating 90 degrees angles, depending on the designs to keep into account. So right here we can see the linear grids: 0 degrees deflection, 15 degrees deflection, 30 degrees deflection. So these angles are totally fixed. It means that when the selection is done in the grid, if it's 0 degrees deflation, it's always going to be 0, 15. So one of the applications for this kind of grid is the floor application, which could be done for supplying airs or microclimates, and we made this air supplying. So this grid or this screen allows to have a moderate traffic over there. And in the chart selection, we can see the linear bar grills. So right here, we have some selections of the grills. So in the rows, we're going to find an important characteristic, and is the height. The height of the grills, they have 1.5 inches up to 2 inches. And right here, we have these up to 6 inches, and the maximum height is 12. And the characteristics inside the chart here in the columns, we're going to find the outlet velocity, the grids or the grills in FPNs, 500 to 1,300. So the flow characteristic, we can find it right here depending on the height of the grills or the grid. So if the height is changing, we can obtain a flow, superior flow, depending on this height. So it's important to keep on mind that these flows are per feet, CFM per feet. So once I increase 1 feet or 12 inches in this case in length of the grids, this flow is going to be effective in the number of feet that I am adding, which also means that if I have a grill that has 12 inches length and 3 inches height, when I increase in 12 inches the length, therefore this flow it's going to be increased in 2. So one grill that is 1 feet and 3 feet height has a range of 65 CFM per feet up to 169 CFM per feet. If I add or increase the length in 1 feet, I'm going to have 34 inches. So this flow will pass from 65 to 130 CFM, and from 169 to 338 CFM. So the grids or the grills, they can have distribution of the earth for the floors. And inside the characteristics of the selection, we can see these characteristics when we have the grills in a specific location for supplying. So we have linear diffusers, LSD. These linear diffusers is a product that is designed to offer a new concept in the distributions on slots. The flaps offer a wide range of configurations, which provides an optimal angle for the throats and for horizontal flow of the air, which also allows to cover a very good area for conditioning. It also has the characteristic or feature that its condition allows modulation for long lengths continuously, installing parts connected in order to reach these required lengths. As an important characteristic, as a unit is manufactured from 12 inches up to 72 inches. Over that, it could be modulated. The number of slots is from 1 to 8 slots. It could be for supplying or for returning error. It also could be installed in the corner with angles to 90 degrees, depending on the design. Geometrical features have the linear diffusers LSD. So we have that the lengths, this length right here, A, goes from 2 up to 72 inches. The slots are the places where the air is coming out, or where the air is supplied or the air is returned. Those are the slots. They could vary from 1 inch, 3/4, or half inch. The flaps of the diffusers, they are movable, so this allows the air to have a direction to a specific direction depending on the characteristics of the application. Diffusers, as a characteristic as well, they have some lateral accessories. They could be taken away for getting superior lengths depending on the product. So they can be modulated, always keeping the aesthetic of the product in order to make links over 72 inches. Right here, we have the selection charts, and we see that there is a chart and a selection chart for the slot of the diffuser, which means that in the chart you can see, for example, 1 inch slot, there is a chart for the slot of 3/4, and there is a chart for the slot at half inch. So this one is a chart for slots of 1 inch. So the slots or the air outlets could be done from 1 slot up to 8 for the presentations. So right here we have only 6 slots, maximum slots of linear diffusers. And right here in the chart we have different characteristics like airflow, static pressure, noise criteria, horizontal throw depending on the velocities at maximum throws, vertical throws up to 150. The linear diffusers in this chart for the selections, they are giving us the characteristics for 1 feet, 1 diffuser, linear with 3 slots of 1 inch in the slot, and 1 length of 1 feet has a range from 20 up to 178 CFM. If we increase in 3 feet the length, this value is multiplied times 3. It means that 20 CFM is not being injected, but 60. And 178 is not being injected by 538 CFMs. And once we increase the length, the proportions is increased, the flow, the airflow of the diffuser, depending on the chart that we are checking right now. Linear diffusers could be used for returning, also to keeping the aesthetic of the product, the installed product. and not having other kind of elements that made the static to be lost. So right here we can see a graph for the distribution of air, where we can see that if we have the open flaps, we are going to have an airflow or air outlet in these ways, and in the occupation area we are going to have the distribution in these ways. If we change the openings of the flaps, so what we are going to have is a total different distribution in the occupation area depending on the area. So right here we can see, for example, the product installed in a modular way. When the product is installed just like this, what we do, we have modules with some specific lengths, and when they are getting together, it shapes the final presentation depending on the features or the design characteristics. And other diffusers that is very important are the high velocity diffusers, L1300. So these diffusers are universal for the managing of high volumes of airflow. They are manufactured in steels, in aluminum. So their dimensions are used for modulated ceilings, 60 times 63 or 24 up to 24. So the characteristics, they have different two cones, for example, three cones, diffusers with isolation in fiberglass. They have necks or diameters in the necks for 6 inches, 8, 10, 12, up to 14 inches. They are available with damper, radial damper. The damper is activated always from the front part with a manual mechanisms or with a key. So right here we can see the installed products installed in the ceiling, in a modulated ceiling with some standard. So right here we can see a summarized chart depending on the grills or diffusers, depending on the induction rate. Checking right here the ones that have a bigger induction, and this right here is related with the heights, 3 meters, 4.5, and 8 meters. So we can see right here what are the segments or it's a diffuser that has a higher induction and what are the heights they are able to work. We can see right here also a chart that shows the prices of the product depending on the height in which it's going to be used. So this also applies for countries where we have distribution of the products. Some countries have all the products available. Some other countries, they don't have all them yet. But this shows what are the products. The cheaper one or the most expensive one, depending on the height, recommended heights. Well, thank you very much, and I hope this information has been very useful for you.